In this video, we're going to do a problem that's similar to question 6 from homework 10.2. First, let's read question 6 together to make sure we can understand it, and then we'll do a similar problem on a separate piece of paper. So it says, and I'm going to go ahead and scroll over here so I can read it fully. It says, use the definition of rational exponents, that means fractional exponents, to write each of the following with the appropriate root and then simplify. So we've learned that to the 1/4 power is notation for the fourth root. Since we have parentheses around this entire fraction, we're being asked what's the fourth root of 625 over 16. Said another way, we're being asked what number times itself 4 times is 625 divided by 16. Let's do a similar problem. So here, I'm giving you the fifth root, right? That what we have learned with fractional exponents is that the denominator is the root that you are taking. Right? So this is the fifth root of 243 all over 32. The question here is what number times itself 5 times, i.e. to the 5th power, is 243 all over 32. Is the number underneath the radical. Right? And if you don't know perfect powers of 5, that's understandable. One thing that can simplify our thinking here is because we've got division, I can actually compartmentalize my thinking and consider the fifth root of 243. And then consider the fifth root of 32. Consider those two separately. You can actually just Google like perfect powers of 5, but I'm going to go ahead and show you on Desmos how to quickly generate a table of values to give you perfect powers of anything. Perfect powers of 3, perfect powers of 2, etc. So this is entirely optional. What I've done is I've come to desmos.com, D-E-S-M-O-S. That's Google's online graphing calculator. And I'm going to insert a table of values. I'm going to scroll over here and I want my inputs to just be x. And I want my outputs to be x to the 5th power. Oops. To the 5th power. Right? And then let's just generate an input-output table. 1, 2, 3, 4, 5, 6. Okay, the value of this is that it's told me perfect powers of 5. So like 32 is 2 to the 5th. 243 is 3 to the 5th. 1024 is 4 times itself 5 times. It's 4 to the 5th. So notice that these two numbers showed up here. I gave us perfect powers of 5 on purpose. Right? You can also use trial and error if you're not familiar with these numbers. So 243 is 3 times itself 5 times. And 32 is 2 times itself 5 times. The fifth root of something to the 5th power is just that thing. So the fifth root of 3 to the 5th is 3. And the fifth root of 2 to the 5th is just 2. So here's my answer, 3/2. The numbers are different, but the concept and the approach for this problem, problem number 3, it's actually not number 3, what is it? It's number 6 are identical.